We've looked at different number-based systems, theoretically, but what is included in the C++ language that can help us out? It turns out there's quite a bit. In this little program, I'm going to go through what those things are. So let's begin just by looking at the code that you see here. And you can tell that I'm going to use some new manipulators. We haven't talked about manipulators in a while, but we have three that come into play here that are really useful if you need to have the output in either hexadecimal or in octal. So let's go through the program and let's look at this. To begin with, I just have an integer number declared to be 64. You can declare variables to be of different bases if you want to. All along, anytime we've declared a variable and we've given it a number, and then we've assumed it to be a base 10 number, and that's true. It is a base 10 number. But if you want to designate a value to be a base 8 number, an octal number, then there's a special notation that we can use for that. So I'm just going to put a line of code in here. So let's plop that in. And here is the way that you designate a base 8 number. Now, the leading 0 here is meaningful. If you precede a value with a 0, that being an integer or an unsigned integer, then that means that this is going to be interpreted as a base 8 number. Now, I can hover over this, and you can see the little pop-up there, and it says that that's an integer 15. So that's the decimal equivalent that pops up. So one thing to remember is if you precede a number with a 0, then that means that it is an octal number, base 8. You might imagine we can do the same thing with a hexadecimal. There's a special notation that we can use for that as well, and it looks like this. If you precede the number with a 0 and an X, then that designates this to be a base 16 number, a hexadecimal number. And again, in Visual Studio, if I hover over this, then you can see that the equivalent in decimal is 33. So that makes sense. Okay, that's 2 times 16 is 32, and then 1 here is 33. So here are the two new notations, leading 0 for octal, leading 0x to represent hexadecimal. Now let's just print those three numbers out so we can see what we get when we print that information. So I'm going to put a cout statement in here, and we'll run the program and look at the output. So we'll print out our regular base 10 number 64, we'll print out our octal value, and we'll print out our hexadecimal value all on separate lines. Let's bring the output over, and here you see the numbers. So we did get 64, as you'd expect, base 10, but when we print out our octal value, we get 15, and then we get 33 for the hexadecimal value. So when we're printing these numbers back to the screen, they're still going to be output in a base 10 form. All right, now let's move on, and what I'm going to do in this program is I'm going to just convert from one to the other, and I'm going to print out the values to the screen. So here I'm going to print out number-based conversion, and then the first thing will be we're going to enter a number in decimal, and it'll be converted to hexadecimal and to octal, and we are going to use those manipulators to do that. So let's go ahead and let's add the code to make that work. So here's the code to do that. We're just going to type in a number in the usual fashion, just using cin, and we'll read in a value for number. Then I'm going to print it out in the different bases. So first of all, I'm just going to print out a small table here. So I've got a set width of 10, and I'll print out the word decimal. Another set width of 10, then I'll print out the word octal. And then hexadecimal is a long word, so I have a set width of 15 for that. Then we will print out the actual numbers and we'll convert them. So to begin with, we just print out our decimal number in a width of 10. So we just print out number. Then we are going to print out that same decimal value as a base 8 number. So we'll set our output width to 10 to correspond to the one up above it. But here is the important thing. We're going to use a new manipulator, OCT. So that means that the thing that follows is going to be considered a base 8 number. And in fact, all the other integers are going to be considered octal unless we change it to something else. So the OCT manipulator is one that stays in effect until we change it back to something else. So this will print out the number we type in, but it'll print it out as a base 8. So it converts decimal to octal. So that's nice. Then we will also print out that same input as a hexadecimal number. So we'll set our width to 15, but this time we'll use the hex manipulator, HEX. That means that the next thing that's printed out, as well as any other following integer values, those will be output as a base 16 number. So by using these manipulators, it's really easy to convert from a base 10 number to a base 8 or to a base 16. So now let's run the program and let's enter a decimal value, and we'll print out the two equivalents in octal and hex. The program's running, so let's look at the output screen. So here we are. We just have output the previous three numbers. We'll leave that in there. Then we are here, enter a number decimal. It will be converted to hex and octal. Okay, so we are right there in the program. So let's type in a number. Okay, well, let's just type in a number that we know for the other values here. So let's type in, let's say 64 is going to be our number. Okay, we know from, well, that's fine. We'll use that number. So I'll enter it. And here we get the decimal value. Well, that's 64. That's right, because we entered 64. The octal equivalent is 100. A hexadecimal is 40. So if you remember when we were converting those in an earlier video, then if we have octal, that's 8 to the 0, that's 8 to the first, and then this is 8 squared. So we have the 1 there, so that's 8 squared, that's 64. So sure enough, 64 decimal is 100 octal. And then we have 40 for our hexadecimal value. So the first digit is 16 to the 0, which is 1. And the next one is just 16 to the first power, which is 16. And 4 times that is 64. So that gives us a little table then. We have the decimal value, and we have the octal and the hex equivalents. Now, let's move down, and let's enter a value that is in hexadecimal. We have a system pause there, so I'm just going to delete that one because we have another one further down. It's down here. And the next thing we're going to do is to enter a number in base 16, and it will be converted to decimal and octal. So we've done the first one, we've done decimal, and we've gotten the other two bases. Now let's start with hexadecimal, and we'll get decimal and octal. So we need to add the code right here to do that. So we can put the code here, and here's what it looks like. Now there's something brand new here as well. How do you enter a number in hexadecimal? We want to type in a number from the keyboard in a base 16 form. The way we do that is we call on the function setBase. So when you specify this, that means that the number that you type in will be considered a hexadecimal value. So it's ordinary CIN, and you've seen we've used a lot of these on cout, but here's one we're going to use with CIN. This is not really a manipulator, it's just a call to a function that will set the base for the next input value. So we'll set the base to 16 here, then we will read in the number and put it in the variable hex value here, and then I'll just print out an end line. Then we will output the three numbers in decimal, octal, and hexadecimal. So this first line here just prints out the header the same way we did up above, and then we'll print out the numbers. So since the input value is in hex, we want to print out the decimal value by preceding it with our other manipulator, DEC, D-E-C, which means that the next thing to print out is going to be a base 10 number. And I keep saying this, but once you set the base, whether it's decimal, octal, or hex, then that stays in effect until you change it to something else. But since we want to print out all different bases, we are going to use decimal, and we'll print out the number that we just typed in to our hex value variable. Then I'm going to do a set width of 10. I'm going to change the output format to octal. So this will output that hexadecimal value as a base 8 number. And then over here, Since I have used octal previously, if I want to see it output in hex, I need to also set the base back to hexadecimal here. So using the dec, oct, and hex manipulators, we can see all of the numbers. We can see the numbers at all three bases. So now let's run the program. We'll enter a hexadecimal value, and we'll see the other two values that correspond to that. Okay, so here we have the output. And we have to do the first part of this where we type in a number in decimal. So let's go ahead and type in 64. And here you see the results that we just got in the previous example. Now we're here. We want to enter a number in hexadecimal. Well, so we can easily compare them, let's type in the number 40. Okay, so we type in 40 in hexadecimal, we hit enter, and you see we get the equivalent value in base 10 and in base 8. So this takes an input in hex and it outputs in the other two bases, octal and decimal. So let's put the code here now to do the last version of this. Let's take out the system pause from there. We have one at the end of the program, so that's okay. Now, we have done we've done decimal and we've done hexadecimal. So now let's enter a number in octal and we'll convert it to decimal and hexadecimal. In order to type in a number in base 8, we have to use the set base function again. So this time we're going to designate the following input to be an octal value. So we'll set the base to 8, then we will use cin and we'll just use the variable we had up here, octal value. We'll just read in a new value for that and save it. Then we will convert it using the manipulators again. So this cout statement that just prints the column headings, we see the decimal, octal, and hex as we did before. And we want to print out octval in all three bases. So decimal comes first, so we'll use the decimal manipulator. We'll print out our octal value, and that will come out as a base 10 number. Then we are going to take away the dec manipulator and go back to base 8 with the oct manipulator and print out the value here. So that would be the same number we type in as an octal value. And then we want to see that same thing as a hexadecimal value. So we'll use our hex manipulator here and we'll print out that same octal value. So we'll input base 8 and we'll output all three. And then we'll have examples of all three cases. So let's compile the program and look at the output. So here's the output screen, and let's look at all three cases. So this is asking for decimal, so I'll input 64. Got to type here first, okay, 64. So now we see the first example. Now we'll enter the hexadecimal value, 40. And we see that that's converted to decimal and octal. Now let's type in our octal value. So if we want to have the same numbers, I'll enter 100 octal. I hit enter, and then we get the decimal value and the hexadecimal value. So now you can use these manipulators and you can easily convert from one base to another if you want to see the different values on screen. Now let's just run the program again and let's type in some different values. Let's use an easy example again. Let's type in the number 15. That's decimal. So we see it's 17 in octal and it's the letter F in hexadecimal. Let's type in the hexadecimal value. We'll put in F and we hit enter. And you see we get the octal and the decimal. And then if we want to enter the value in octal, then we can type in 17 and we see all three numbers again. Okay, let's run another example. Let's use another common computer science base 2 power of 2 number. Let's try 256. Okay, so that's going to be decimal. So that's 400 octal and it's 100 hexadecimal. And that one's pretty easy because we know that this is going to be 16 squared over here. So we know that's 256. Now let's do the others. Let's type in the value in hexadecimal, which is 100. And then we'll type in the octal equivalent, which is 400. And you see we still get those numbers. Now let's try one more example. So let's type in a value for our decimal value this time. So let's type in, let's just say 1200. Try that again, 1200. So I'll type that in, And here we get the octal equivalent and we get the hexadecimal, which is 4B0. Now this says enter a number in hexadecimal and it will be converted. Well, we know that we can use letters A, B, C, D, E, and F for hexadecimal values. So let's try some of those. Let's type in, FF, and we hit enter, and you get the equivalent. Decimal's 255, octal's 377. Now, let's enter our octal number, but let's try to fool it a little bit here. With octal values, we can't use an 8 or a 9. So what would happen if we type in a number that uses an 8 or a 9? So let's type in, for example, 189. Now what's it going to give us in this case? Well, let's try it. I hit enter, and notice that it did not read the 8 or the 9. So it picked up the 1 and it used that, but it did not recognize the 8 or a 9 because those are not legitimate hexadecimal symbols. You can't use an 8 or a 9. So it didn't give me an error message. It just ignored the 8 and the 9. So when you are using these various manipulators, you need to be aware of that. You're not going to make your program abort and when you type in a symbol that's not allowed. And the same thing would happen if we did our hexadecimal. We typed in X, Y, and Z up there. So the program's not going to abort, but it will not give you what you wanted. So be aware of that. All right, well, this little example then illustrates the manipulators oct, dec, and hex. So you can use those if you want to have a value that's in some base and you want to see it in the other two bases. You might wonder if we can enter a binary number and then convert it to one of the other bases. As it turns out, you can't. This only works with the three number base systems shown here. We have octal, hexadecimal, and decimal. So let's bring in our reference and take a look at that. So here I've gone to c++.com, one of my favorite reference locations, and I've looked up set base. So as you can see here in the documentation, it only allows you to do base 10, hexadecimal, or octal, and if you want any other base, then you can set it back to 0. But there is no set base to 2 or 5 or 12 or anything like that. So it only works for those three number-based systems. So we can't do binary, unfortunately. We can't just set it to binary and type in a binary number. So that one's not allowed. All right, well, this little program then may come in useful if you have a situation where you want to output some information in a base other than our standard base 10 number system. Remember, the manipulators oct, dec, and hex, remember they stay in effect until they're changed to something else. And I think that covers those, so we will stop the video at this point.